Acid chlorides can also be used to make amides. But when you make an amide from an acid chloride, you must use an excess of an amine. So, the mechanism is the acid chloride acts as a good electrophile. The amine is your nucleophile. So the nitrogen adds to the carbonyl, electrons go up onto the oxygen. Like so. And the electrons come back down and kick a chloride off. At this stage, you get a protonated amide. Protonated amide is very acidic. And amines are typically basic. And your amine comes in, takes that proton off to generate your amide, plus one equivalent of your protonated amine. This is not a nucleophile. It's not even a weak nucleophile. It's not a nucleophile, period, because you no longer have the lone pair that you need. So that's why you need an excess to drive this reaction to completion. Otherwise, the reaction stops halfway, where half of the reaction, half of your amine has been consumed, half of your acid chloride has been consumed. The remaining half of your amine is just this protonated form. Now, this is not particularly a good method if your amine is expensive because you're burning half of your amine in this protonated form. Now, you can use this method with primary amines or secondary amines. We have 2 carbon substituents on this. It will not work when your amine is a tertiary amine. And so, if you have an expensive amine, you can use this fact here that it doesn't work with a tertiary amine. And so what you can do is set it up so you use the amine that you want to make the amide out of, plus you add a tertiary amine, like triethylamine. Triethylamine is very cheap, and so it's usually the one that's used in this. And as a result, you get this, plus the protonated triethylamine. Triethylamine won't add to the acid chloride because it doesn't have any way of removing one of these groups, meaning nitrogen adds here, electrons go up, and these electrons come down, kick off the chloride. This doesn't have a proton you can pull off to leave the positive charge on that nitrogen. As a result, this goes backwards. It doesn't add at all to it because you don't have the stabilizing form of amide resonance illustrated up here. Okay? So this really has no choice but to have the ethylamine attack. Electrons come down, kick the chloride off. Get this? Now, on this deal, either the triethylamine takes that proton off and you generate your amide and the protonated triethylamine, or what can happen is another ethylamine can take this proton off. The triethylamine case, that's easy. That's what gives you the product. But say if an ethylamine stumbles by that proton, what's happened here then is we've blocked off one of the nitrogens that we want to use as a nucleophile later on with the next round. But since we had triethylamine present, triethylamine can simply deprotonate the ethylamine, and this is a reversible reaction. Like so. And this frees up the this frees up the ethylamine to go back through and find another acid chloride. And so the reaction can go to completion. So there are two ways of making an amide from acid chloride. Either use an acid chloride in excess amine, or use the amine and then also triethylamine with it.